Hi students, my dear students everywhere. You'll be starting Mechanics 1, Edexcel or Cambridge. We are in chapter 3 in M1, which is Edexcel book. So, because I'm teaching in specific my Edexcel students, but this in general we are in Dynamics 1. We are in Dynamics. We are in Dynamics. Part 1. What do you mean by dynamics? And what are we doing in this chapter? We are doing resolving. We are resolving forces of or acting on a moving particle. This is the meaning of dynamics. Particle accelerating. Good. That will be studying now cases of motion. According to the case of motion, we'll be using Newton's second law, or the equation of motion, F equals ma. Now according to the case of motion, you'll be studying the cases of the forces acting on the particle, like you'll be studying now in the first lesson in dynamics. This is that we'll be studying. Okay? Let's continue now starting the cases. According to the cases of motion, I'll be writing what I'm saying. According to the case of motion, we will be resolving forces and then writing the equations of motion. Using F equals ma. This is that we are doing. For example, case number 1, my dear students. Case number 1. When a particle is moving on horizontal plane. Case number 1, a particle is moving on a horizontal plane or surface. Which is this one. This is the surface and the particle with m kilograms. And we are studying the case now, writing and resolving the forces, displaying the free diagram, the forces acting on this particle with case number 1, that the particle is moving on horizontal plane or horizontally. So we have two cases horizontally. So we have to show in this diagram which direction the particle is moving to. So how do you do this? We do display like this. So we mean by this that the particle is accelerating or moving a meter per second squared in this direction. If we have here a force P newtons, so the equation of motion in the horizontal, look, focus well here. We say P is equal to MA. P is equal to MA. Vertically, and it's better to say perpendicular to the plane. Perpendicular to the plane. This is the language that we'll be using now for the whole chapter in dynamics and statics as well. When the particle does not move or does not accelerate, when the particle is at rest, equilibrium case, which is next chapter, we'll be using the same logic. So, in this direction, we have always two forces acting on the particle. R for reaction force and the weight, which is mg to the gravity. Focus well here, it's easy, but we have to understand this well to not be confused or getting confused in the next parts. The weight, which is mg, is always perpendicular to the surface, to the horizontal. Weight is always, and we'll be saying this and focusing on this on the other cases of motion later on. But weight is always perpendicular to the horizontal. Weight, note here, very important note, weight is always perpendicular, makes 90 degrees. If some of you are still not familiar with perpendicular, makes 90 degrees, makes right angle 90 degrees to the horizontal. Always, my dear students, regarding the case of motion, weight always. But R, and I'm explaining this will be recognized and more understood when we move to the next cases in this lesson and the next lessons. Weight always makes 90 degrees with the horizontal. But R, the reaction, R for reaction, normal force. Reaction, or is called normal force. It's perpendicular to the surface of motion. R makes 90 degrees to the surface of motion. And again, I'll be saying it again in this example because it's simple example. We're still introducing this chapter. It will be more clear when you move in the next minutes to the other cases. Okay. If we have more than one force, if we have more than one force acting on a moving particle, what do you do only? We just add the forces in the same direction. At the same time, we subtract the forces in opposite direction. Just let me fix this for the handwriting. All right, we add the forces in the same direction, and I'll be explaining this in the examples now, and we subtract the forces, they oppose each other. But we have to pay attention to a very important thing here. The most important thing we have first, we have to start with the main force. Main. What do you mean by main force? It's the force or forces. It could be force or more than one force. That they are the force. It is the force or forces that is or are, if it's more than one force, in the direction of motion. Or we may say parallel to the direction of motion. Parallel to direction. Let us explain what do we mean by in the direction or parallel or in the direction of motion. Example number one. Example number one. This is the particle of 5 kilograms. Its mass 5 kilogram, and it's moving in this direction with A, accelerates with A meter per second squared, and the force is here, which is, let's say, 12 newtons, and we have force here 8 newtons. Fine. The question wants find A. Simple example. We start with the straightforward cases. So look, this is the direction of motion. In this direction. And 12 Newton, which is here, in the direction of motion. This is that we are meaning, or what do you mean by in the direction of motion? The force is parallel in the direction of A. It's moving to this direction. So 12 is the main force. We call it 12 Newton is the main force. My dear AS students, the main force. So the equation of motion horizontally, this is F equals, that will be using F equals MA. F in this case, what is F in this case? We have two forces. 12 in the direction, and we have 8 Newton opposing 12. So it will be 12 minus 8 is equal to MA, 5, which is M times A. Then implies that 12 minus 8 is 4, is equal to 5A. This gives us A is equal to 4 over 5 meter per second squared. Vertically or perpendicular to the plane are 5G. So the reaction force R for reaction, again, I wrote it before I will write it, is equal to mg, the weight, mg. So in this example, R is equal to 5 times G. And G, as we said, I'm teaching mainly EdXL, the syllabus of EdXL, M1 mechanics in EdXL. G is 9.8 meter per second squared, always. So R is equal to 5 times 9.8, which is 49 newtons. Let's do another example. Example 2. This is a particle of 5 kilograms moving in this direction. And we have force number 1, 6 newtons. Force number 2, 14 newtons. Force number 3, P newtons. and the particle is accelerating. Particle is accelerating. We don't need to write this. So if we don't write like this, and only we write, here we write 2 meters per second squared. We are telling that the particle is accelerating with A is equal to. We don't need to write A is equal to, because the unit here is clear. So when you write this arrow, means it's moving to this direction. It's accelerating in this direction. Yes? Accelerating in this direction. This is the meaning of this arrow. What do you have in this example? And what do you want? The question wants from us here, find A, the reaction force. The reaction force. B, find P. What's the value of P? Solution. Part A, to find R, what are we doing? Vertically or perpendicular to the plane. This with the language that we'll be using for the whole chapter. R is equal to 5G. So 5 times 9.8, 49 newtons. Horizontally, we have to pay attention, be careful that these two forces, 6 and 14, they are in the direction of motion. So 6 and 14, both they are main forces. As we said, 6 is the direction of motion and 14 as well. So what's the main force in this? 6 and 14. So we add them. P is opposing them. So 6 plus 14 minus P is equal to 5A. So 6 plus 14 is 20. 20 minus P and A is 2. 5 times 2. So P is equal to 20 minus 10, which is 10 newtons. Easy? I'm a bit fast in this because this is easy to understand. But I am revising this or going through this chapter from the beginning because I consider like some students, they don't take physics or did not take physics in O-level IGs, but they are doing M1 for some reasons. Wrong decision, not guided well. The most important thing, it's easy to understand. Because of that, we are starting with the straightforward cases. Good. Let's focus on something before we move to the next cases. This topic is one of the most important topics, and certainly every year in M1 exams you will be asked about this chapter in M1 exams. Just we have to focus, summarize what you understand as note. We wrote it like between the notes before, between the lesson notes, but during the lesson notes, but I will be writing here very important. 1, weight, which is mg, my dear students. It's always perpendicular to the horizontal, always to the horizon. But R is always perpendicular to the surface of motion. We have to understand this well. And it will be more clear. It will be more clear when we move after this part. After the next case, you'll understand this, why it's important. You will be recognizing why I'm writing this in the next parts. Always is perpendicular to the surface of motion. Part 2, it's easiest, but we have to say it because some students, and many students, they do this mistake. If a particle is moving. When we say moving, we mean accelerating. Horizontally, it does not, my dear students, accelerate vertically. Sketch example on what I'm saying. The examples that we did, both of them, if the particle is accelerating in this direction or in this direction. And if you have forces or more here, we don't care. Yeah? F net, F resultant, we'll be solving it in the next part, is equal to MA. Because the particle is moving to the left or to the right, or due east and west. We use this language at the end of Umm1 in the coming chapters. But R, why R is always equal to mg? Because R minus mg is equal to 0. There is no acceleration in this part, in this direction. Because of this gives R equals mg, my dear students. We have to make sure that we understand this part well. If the particle is moving in this direction or this direction, so it does not accelerate, because some students, they put both F resultant, that the resolving forces in the direction here, the horizontally, equals MA, and they put R minus this mistake. They do this mistake. Minus mg equals MA also. What do you mean by this? Does it make sense? We are studying one-dimensional motion. One-dimensional. The particle is moving in this direction. In this direction. So it does not accelerate vertically. So always this part is 0, my dear students. Is 0. Because of this, always R equals mg in this sketch, in this example. R equals mg. In the next parts, we'll be seeing that R equals other components of weight, as we'll be understanding in the next parts. All right?